Awesome, thanks, Genesis. Today, our topic is going to be functions, but we're going to be looking at something called function notation. It's a notation, yeah, I spelled that right. It's a fancy lesson today. That's how I like to think about it. Function notation just means how do you write a function? How do you show it? Mathematicians came up with a different way of showing functions that really is useful because it saves you a lot of time writing them out, and actually it conveys a lot of information without having to do a lot of work, which middle school students always like. They don't like to do a bunch of work most of the time. You guys like to find the shortcuts. And function notation allows us to show a lot of information very with very few kind of things in it. So let's talk about kind of how that looks. With functions, you can ask three things. Let's see. How do I want to write this? I'll write it up. 3 questions you might ask. Not you, it could be anyone. 3 questions someone might ask when they're looking at a function. They might ask, what's the output? That's usually the most common one. Like if you were an engineer and you were designing something, and maybe you were designing airplanes. I'm going to change that. I don't like my writing there. Maybe you were designing airplanes, and the computer you were using was telling the airplane like how fast it needs to be going or how fast it can climb. That's like your output. And so there's something going on, and so you might ask, well, what's the output of this machine that I'm working with? The other thing that you might ask would be, what's the input? And that's kind of more like a science kind of question is, hey, we're observing this, we're watching all this stuff happen, but what was the input that caused it to happen? And then there's a third question we ask, and this comes up a lot in math and in like computer coding, is what's the rule? What's the rule that's happening inside of the function? And when we were doing the activity earlier this week, a lot of you were thinking about that as we were doing the inputs and outputs, because your brain just kind of goes there looking for those patterns, and you're thinking, okay, well, what mathematically is going on here? So these are the 3, there might be more, but these are the 3 main questions that we have when we're looking at a function. And with function notation today, we're going to see how can we ask these different questions and how do we write it out. So first thing we would want to say is we like to give functions names. So I'll say first, we give names to functions. Boy, my handwriting today, I don't like it. We give names to functions, and we love letters in algebra, so we actually use letters for functions. So for instance, you can name them whenever you want, but the most common one that's used would be if we name something like function f. That's the most common one, just because f is function, so we just call it f. You could also call a function like g, function g. And what that just means is like there's some machine, and we're just going to call that machine f. Or there's some machine, we're going to call it g. And we could ask these 3 things. We could say, well, what's the output of f? What's the output, or what's the input to f? What's the rule of f? So instead of saying function every time, we could just say f, we could say g, or you know what, h too. We could say function h. So that's just referring to like the machine, to whatever's causing all this stuff to happen. Now, mathematicians weren't happy with this. We want it to be even shorter. We don't want to write out all that. So another way of saying function f is like this. We write the lowercase f parentheses x. These mean the same thing. This would be function f. This is also function f. These are the same thing. This is just how I write it without using words. How do you think I'd write function g without using words? How do you think I'd write function h without using words? Any ideas? Oh, nice, Tina. I like it. Caitlin, Georgia, thank you. So it looks like this. G parentheses x. So the thing that's changing is the thing on the outside. This tells me it's function f. This tells me it's function g. And then this one would be function h. Yeah, no, Tina, that's fine. I see exactly how you got there. I would have thought the same thing. It's a process, it's a discovery. So this is where algebra students get caught up a lot, is they forget what this means. When we just write it like that, you have to remember that means function f. Or this is how you would read it. Actually, no, I'm going to leave it like that. Okay, so those are the names we give to functions. Now, I don't know if this one would always come second, but second, we give functions rules. Or maybe it already has a rule and we figure out what it is. Now, a rule is just an equation. It's maybe you're subtracting 10 every time, or maybe you're adding something every time. It's some mathematical formula going on. So I'm just going to make this up. Let's give function f a rule. Let's say, so first I need to write function f. So function f. Let's say the rule is 2 times x. Then what this means is my function f is equal to 2 times x. That means my function f is following the rule where it's doubling the x's every time. Let's come up with one for function g. Actually, I'll let you guys do it. What rule do we want function g to follow? It can be anything. We're just making it up for our example. And also, what do we want function h to follow? We'll create another rule for him too. Okay, thanks, Jackson. Let's do that. Function g is going to be 4x. That's going to quadruple whatever you put into it. All right, and I'm still waiting for some rule that we want function h to follow. And maybe we can do something different. We could do that, Addison. Let's get to something not just multiplying. Yeah, Caitlin, let's try that one. Let's divide it by 3. So every time you put in a number, you're going to divide it by 3. Okay. So these are all kind of one-step functions, right? All you have to do is one operation and then you're done. Sometimes functions have a whole bunch of different steps, sometimes not. The rules can change, okay? Let's see. What do I want to show you next? Let's create a table. So first we give the names functions. Second, we give the functions rules, or maybe it already has a rule, so we can skip that step. Third, we find inputs and or outputs. Sometimes you find both, sometimes you just find one. The handy way to do that, of course, is with the table. And instead of writing input and output, we use x and y. Remember, x is input, y is output, and we record it into a table. And you get to choose whatever numbers you want for the input. A tip I would say is always do like a mix of different kinds of numbers. The screen is blurry. Okay, let me try changing a setting real quick. I'm gonna go back to this way and see if this makes it better. Okay, this is gonna be our input and output for the function f, right? So I'll even write it up here so we remember. This is for function f, which we said gives the rule of 2x. So what I was gonna say was my tip when you choose your inputs is try a mix, try positives and negative numbers. Maybe try some decimals, maybe some fractions, but definitely try positives and negatives. So I'm just gonna try, I'll just try -1, I'll try 0, and I'll try 1. And so what we do is we plug in the input and we figure out what comes out. So if we put in -1 to 2 times x, we'd get out -2. If we plug in a 0, we get out a 0. If we plug in a 1, then we get out a 2. Okay, so I haven't told you your purpose. So our purpose of today is to be able to recognize function notation and be able to use it and solve with it. So all of this has been set up for a function notation. We talked about how we can give functions names. We talked about how functions have rules. And now we're going to incorporate all of that with our inputs and outputs. So we can leave everything the way it is right here. We just used a function and we found the inputs and outputs. But function notation has us do one more thing. It has us write this in a way that's a lot easier, so we don't have to draw tables all the time. Here's how I can show what I just did using function notation. And this is the most important part of our lesson today. Is what I do is I take my f, that was my function f, right? And here, what this is saying is we're putting in x's into our function, and we're going to double them and see what comes out. So with function notation, you can actually show that by without using a table. And this is like a fancy way to write it. I would write f parentheses -1 equals. So what I'm saying is I'm taking a -1 and I'm putting it into my function f. And then over here, I write, what did we get out? We got out a -2. So notice my input goes into the parentheses and the output is over here on this side. So let me do it down here. I would say I took my function f, I put in a 0, and what did my function equal? What came out? A 0. This is called function notation. It's a faster way to write your tables and to show how the function's working. And then I'll do the last one here. F, we put in a 1 into the function f, and we got out a 2. So today, you need to get good at writing the function notation, and we'll use it to solve some things. Okay, so it just means the same thing the table means. The table shows us inputs and outputs. This also shows us inputs and outputs, just with less writing. Questions, comments, concerns, wonderings? So first, let me back up just a little bit. So the whole point of function notation is so that we can ask these three things. And we said first we give the names to functions. We call them like function f or g or h or whatever you want to call it. We give them rules to follow. And then we find the inputs and outputs. And instead of using a table today, we're going to be using function notation to show our inputs and outputs. So let's try another one. You know what? We're going to skip function g. Let's try function h. And you know what? Why don't I number these? This was the first function we tried. So let's try. We're going to skip the function g. Let's just try the function h. So when I'm using, and we're going to just use function notation this time. We don't need to use a table anymore. First, I say what my function is. I say I'm using function h, and it takes x's as inputs. And what's happening inside, what the rule is we're going to divide the x by 3. And then what I'm going to do is I'm going to kind of run through a table in my head, and I'm going to do a bunch of different inputs. And so I'm going to actually start to write it first. I'm going to say I'm going to take function h, I'm going to put some number in. And I'm going to do it again. I'm going to take function h, I'm going to put some number in. We'll see what comes out. And then I'll do it one more time. Take function h, put some number in, and see what comes out. Okay? We get to choose our inputs. We can choose whatever we want. And let's do some negatives and positive numbers, okay? All right, let's try -6. If we put in a -6, what do we get out? Well, -6 divided by 3 is -2. So that's all I have to write. I don't have to show my work. I don't have to go through all the division. I just did it in my head. If I wanted to, I could go over on the side, show my work, and then my final answer would look like this. This means I put in -6, I got a -2. Let's try putting in a -1. What would our output be? -1/3, right? And then let's try a positive number as well. Let's say 12. We put in a 12, what do we get out? A 4. Questions, comments, concerns, wonderings? So there's a fancy way for us to read these. If I was going to say this to someone, when we see our function like this, I would say, the way I'd read this, I wouldn't say like h parentheses x, or I could say function h, but the faster way is we can say it like this. We could say h of x. That's what that means. Function h of x. So h of x is x divided by 3. Or this one, you read it like this. H of -6 is -2. So this would be h of -1 is -1/3. H of 12 is 4. So function notation gets confusing because of this weird way to write it, because of this weird way to say it. But once you get good at it, it does save you a lot of time and it's really useful. Okay, so we're going to try this now. We're going to try looking at the function notation, and we're going to try asking some of the other questions, like what's the rule, or what's the output, what's the input? Because so far we already knew what the rule was. We already knew what the whole function was. So all we had to do is just plug them in and solve. But sometimes we don't know everything that we need to know about the function. And your homework tonight, or not tonight, but today, is going to look like this next part. Okay, so function notation, how we read it, and now we'll get into using it. And I'm going to have to flip my paper over. I'm out of room here. We'll call this number 3. And make sure I choose a good example here. So one thing we could say is we could say this. We could say Function, let's just use function, a new function f. Let's not use f. So we use f, g, and h already. Let's do function n. N of, let's say, 2 equals. So what this is saying is I have a function n. We don't know what the rule is, but we're going to plug in a 2 into the function. So already I'm showing you two things. I'm showing you that there's a function that we're plugging in a 2, and now I'm going to show you the rule that the function is going to follow. We would say, let's say it's 3x squared. That's all the information we need for this problem. It says there's function n. I'd say n of 2 is 3x squared. So because it's written like this, what it's asking us to do is it's asking us to find what's the output. And I know it's asking us to do that because it shows me right here what the input is. And it shows me right here the rule. And it shows me right here the function that we're calling it n. So would you post in chat, what's our output going to be? Aren't functions weird like that? It's like it has a letter and then a parentheses and then the rule. You have to be careful with order of operations, right? Order of operations says do exponents first and then do multiplication after. So if I wanted to show my work, I might show it like this. We're plugging the 2 in for the x. It's not going to be 36. Because you have to do 2 squared first. Order of operations, PEMDAS. Yeah, 12. So here's how I'd write my final answer then. I plugged in the 2, we solved it, and then what I would do is I would write it in function notation. I would say n of 2 is 12. That's my answer. It shows someone that I used function n, I plugged in a 2, and I got out a 12. Let's talk about a common mistake. No, don't do this next part. Some algebra students like to do this. They see the n, oops, they don't put parentheses around that. Parentheses go around the 2. They see this, they see the n of 2 equals 12. And then what they do is they're like, oh, that's multiplication. So I'm just going to divide both sides by 2, and then I get n equals 6. No, don't do that. That's true if it was multiplication, but this isn't multiplication. This is function notation. This is saying n of 2 is 12. So you don't divide. There's no multiplying going on there. This is just showing us what went into the function. Okay, I hope that makes sense. Please don't try to like go another step. There's nothing else to do. There's no multiplication going on there. Here's another way you might see it. Let's see. Let's use j for our function. Let's say there's some function j. We're going to say, this is number 4. J of x equals You know what? I kind of like that exponent from before. Let's try something like that again. It equals x squared, minus x. That's a cool rule. Okay. So already I can tell I have a function j, and I already know what the rule is. But then we might see it like this. We might see the function, and then it says like when x equals, let's say, -7. So see, mathematicians don't like to write very much, and that can be confusing sometimes to someone reading this. But here's what it's saying is going on. It's saying, here's a function, here's the rule, what happens when your input is -7, okay? So if you can figure that out, can you post your answer in chat? So let's see, we're solving, right? We're solving functions using function notations. We're saying, what's our output when we input this? So I guess that might be a helpful tip for us, is knowing what we're asking, right? Here's asking, what's the output? And they gave you the input, they gave you the rule, they gave you everything you need to know. Any ideas what the output's gonna be? And remember, function notation can get confusing, but if you want, you could go back to tables. That's all we're doing. We're just using a table, and we're saying, here's our rule, here's the input, what's the output? Awesome ideas. Thanks, Cooper. Thanks, Jackson, Caitlin, Tina. Here's how you would show your work. I'm going to take my function j, and I'm going to change the x, because this is just saying that's my input, but I know what my input is. It's -7. So I'm going to say, what happens when I put in -7 into function j? Well, what needs to happen? I need to do -7 squared minus -7. Ooh, Georgia, that's in function notation. Well done. That's the thing too, when we get to our answer, we always want our answer to look like this, because it shows us a lot of stuff. It shows us the function, the input, and the output. So let me finish this one. -7 squared, -7 times -7 is positive. Minus negative is the same as just plus. So what do we get? We got 56. Yeah, and remember though, you want to write everything here. We want to say j of -7 is 56, or j of -7 gave us 56. So you're going to see two things on your homework today. You're going to see things like this that we started with, and when you see that, it's saying figure out the output. So plug it in and solve. You might see it like this, where it was in the parentheses. It's the same thing. It says put in a 2 and see what you get out. Both of them are asking what's the output.